So what about the other build tools we all know and love? Firstly, there's ANT, which stands for, or at least used to stand for, Another Neat Tool. Probably the first Java build tool, written when people got very frustrated with using make. A guy named James Duncan Davison came along, who was a Sun employee at the time, realized that make was failing us and decided to write a build tool. At the time, XML was used for everything, so we used XML to create the tool, and the tool he came up with was ANT. So ANT provides us with an XML build script that's hard to read and difficult to maintain. So this is an ANT build script for a fairly simple application that consists essentially of one jar file that we're going to build. There are some library jar files to include. One of the big issues with ANT is the lack of conventions. So we have to specify everything, from where our source directory lives, to where the classes will be built, to where we're going to get libraries from, to where we're going to output anything that we create here. If we look at this file, we'll find there are many properties here to specify this information. And then here, a set of targets. So for example, it's a prepare target that creates the directories that we need. There's a build target that allows us to build the code. But notice again, there's no conventions. So for all the targets, we have to specify absolutely everything that we need. ANT files can get very large very quickly and become very unmaintainable. And as we can see from this, very unreadable. So what about Maven? Well, I think Maven has several advantages over ANT. Firstly, it has many conventions. So we don't have to specify where we're going to get our sources from or where to build the output to. Maven already understands that. Maven also supports dependency management. So here, for example, we can see we're specifying we have a dependency on servlets, and it will go and find those dependencies and download them for us. We don't need to worry about carrying those jar files along with us. The Maven POM will allow us to specify the dependencies and then resolve the dependencies when we need them. Maven is also highly extensible. So we can configure Maven with plugins, unlike ANT, where everything has to be defined by us. However, like ANT, Maven is written in XML, and like ANT, it's hard to read and can be unmaintainable. So what about Gradle? This is an example of a Gradle build file, called build.gradle. Here we can see we write the build file in a language that's specific to this domain, to the build domain. So this is an example of our domain-specific language. You can see we are specifying repositories to use, plugins to use, dependencies to use. We also have some extra stuff here. We need some setup to do integration tests. And again, we can see how we apply that within the build file. Now at this point, you might be looking at this and wondering what on earth is going on. It's like nothing you may have seen before. It's certainly not XML. However, we'll see as we work through the rest of the class that build files, because of the DSL, become largely self-explanatory and relatively easy to maintain and manage. And this DSL is one of Gradle's strengths.